Okay, hopefully you can see this, Campbell. So for number 14, you're supposed to use the information that's given in the diagram to write a proof. So first we need to look at the picture or at the diagram. When we do a two-column proof, we always state the given information first, right? So what is our given information there? We see that AD is congruent to DC. And then we see that angle BDC is a right angle. And then, so now when we're doing a proof, we're going to go back and look at the information that's given and see what else we can prove from that. So if we look at where it tells us that angle BDC is a right angle, what else can we figure out from that? Sorry, I know the screen kind of goes way out when I have it open like this. Okay, we do know that it's perpendicular, but what do we know about the other angle there? This angle here. We'll know that ADB is congruent with CDB. And that's because all right angles are congruent. Okay. And then, so if we're trying to prove that angle ABD, so this angle, and angle CBD are congruent, that's our ultimate goal. Okay. The next thing we need to know or need to look at probably is just trying to prove those two triangles are congruent to each other. So if we look at this, we know that they have one congruent side here. And then we know that they have a congruent angle. And then this side here we know is also congruent. And that is because of the reflexive property. Right? So now we proved triangle ABD is congruent to triangle CBD. I'm running out of room over here. ABD is congruent to triangle CBD because of side, angle, side, right? And then finally, what we're trying to prove is that those angles are congruent. ABD is congruent to angle CBD because of CPCTC. Does that make sense, Campbell? Okay, good. You're welcome. Isabel or Lily, you guys have questions? Number 14 on 5.2, Lily? Okay. So number 14 on 5.2 says, first we're looking at the top part. A restaurant chain is planning to build a distribution center that's convenient to its 3 restaurants. The diagram shows the locations of the restaurants, and the locations form a triangle. Okay. Bye, Campbell. Let me, you know what? I'm going to do this a different way. All right, can you guys see the problem on there now? Okay, so if we're looking at the picture, the diagram shows the location of the three restaurants and they form a triangle. Isn't that fancy? So for number 14, in the diagram, how could you find a point that is equidistant from each location? So, and then explain your answer. So for that, we're going to have to go back to the chapter and to the theorems that we have and see what we can use. What we can use from those theorems that the chapter tells us. Do either of you know which theorem we're going to use? Well, here, let's look at this, okay? Let me see. I'm trying to share another picture for you. Yeah, Isabel, we're going to use, and Lily, both of you. Yeah, good job. We're going to use the concurrency of perpendicular bisectors. So concurrency is, remember we said that's when they're all there at the same time. So if we read this theorem, the perpendicular bisectors of a triangle intersect at a point that's equidistant from the vertices of the triangle. So that's what we're trying to do there with that other problem is we're trying to find a place that's equidistant from all of the vertices because that's where they want to put the distribution center, a place where it's equal distance to all of their restaurants, to all three of their restaurants, right? So the way that you can find the point that's equidistant from them is to draw your perpendicular bisectors. Let me see if I can go back and show the other problem now. Okay, so if we draw the perpendicular bisectors on here, remember a perpendicular bisector comes in from the midpoint of the side. So if we figure we can measure the distance from these two restaurants, right, and get the middle, measure the distance here and get the middle, and then measure the distance from these two and get the middle. And now perpendicular is going to go straight up from all of those. I cannot draw a straight line. You guys know this. So we're going to draw all of these perpendicular bisectors. And then now where the perpendicular bisectors meet, let me go back again. So the perpendicular bisectors of a triangle intersect at a point that's equidistant from the vertices. So these perpendicular bisectors, where they intersect, I guess I didn't draw that very well in the picture. This point here, where they intersect in the middle, is a point that is equidistant from all of the vertices. So if we construct perpendicular bisectors, then that will be the point where they all meet is where we'll find the middle or the point that's equidistant from all of those vertices. Does that make sense, or did I talk too much? How about you, Lily? Okay. I probably talked too much. So let's look at it. When we look at this theorem, 5.4, okay, the perpendicular bisectors, remember, are the blue lines, okay? They're this part here, all right? They're this line, and this line. Because it's a bisector, so it divides that side in two, all right? So AB is bisected by this blue line here, okay? BC is bisected by this line. And then AC is bisected by this line. And what we know is that the perpendicular bisectors intersect at a point that is equidistant. That means it's the same distance from the vertices. Now, perpendicular bisectors go from the side, but if you were to draw a line from the vertices down to the perpendicular bisector point, or to the middle point where they all meet, these lines are all congruent, okay? Does that make better sense? Okay, so on the restaurant, let me see if I can go back. On this restaurant picture, in the diagram, how could you find a point that's equidistant from each location? Well, we know that the point that is equidistant from each location is where the perpendicular bisectors meet. So we would draw a perpendicular bisector here, a perpendicular bisector in from here, and a perpendicular bisector in from here. And the point where all three of those meet is equidistant from all of the vertices. So on this one, it would be here. Actually, let me change colors. Maybe that will help. So that would tell us that that distance, this distance, and this distance from each restaurant to this point where all the perpendicular bisectors are is all congruent. So that's what we would do. You're going to construct perpendicular bisectors. And the point of concurrency or point of concurrency where they all meet is where the distribution center should be. Any better? Okay, good job, Lily. All right, Megan, so this is on the screen right now is number 14 on practice A. And basically, you're supposed to tell how you can find a point that's equidistant from each location. So if you look at theorem 5.4 in the chapter, it tells you that where all of the perpendicular bisectors meet is the point that is equidistant from all of the vertices. So these yellow lines that I drew on here are the perpendicular bisectors. And where they all meet is if we draw a point or draw a line out from there going to the vertices or to the location of the restaurants, that segment is congruent. So the distance from that point out to each restaurant is equal. Does that make sense, Megan? Okay. Okay, I finally got it pulled up, Megan. So if we look at number 10, we're supposed to explain why the conclusion of this problem is not correct given the information in the diagram. So if we look here, the conclusion is that AB will pass through point C. So the assumption there is that point C is on this line with AB. Now, in order for that to be the case, we know AB is the perpendicular bisector of ED because we see that it divided that side into two equal parts and it's a perpendicular line with that segment. So we know AB is the perpendicular bisector. But do we have enough information to show that C is also on that perpendicular bisector? Now, if you look at the theorems in the chapter, so theorem 5.2 says, in a plane, if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of the segment. So that's not the one that we need to use because we don't know that it's on the perpendicular bisector. So let's look at the converse, the theorem 5.3. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if we look there, we don't know that it's equidistant from the endpoints because we have endpoint here of D and E, but there's no information here to tell us that that's the same measure for those two sides. So we don't know, we can't just assume that it's on the perpendicular bisector because the two sides are not congruent. Does that make sense? You're welcome. Okay, Isabel, so for number 11, you're supposed to tell whether the information in the diagram allows you to conclude that C is on the perpendicular bisector of AB. So if we look back at the theorems in the section, look at the one that says, let me pull it up. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So do we know that point C is equidistant from the endpoints of our segment AB? Yes. So there is enough information to prove that. And it would be because it's equidistant from the endpoints of AB. And then you said number 13. Okay, so if we look at number 13, some roofs are built with wooden trusses. An attic truss provides storage space within the roof. Let segment BI, FH, and DJ be perpendicular bisectors of the sides. If CI equals 7, JE equals 10, and EH equals 7, then find the length of AG. So that's this whole side down here, okay? So what we have to do then is we have to kind of look at the different things that we can prove about the triangle. All right. We know that BI is a perpendicular bisector. So that would be a perpendicular bisector of this triangle here. Okay. So that's going to tell us that that part is congruent with this part. So it's also 5. FH is a perpendicular bisector. So that will be a bisector of this triangle. So that will tell us that these parts are also congruent, which is 5. So then we have to figure out what this length and this length are. Now, if we know that FH and BI are perpendicular bisectors, then we know that H and I are points that are on the perpendicular bisector. Now, if you look, I don't know where my screen went. If you look back in the chapter at theorem 5.2, what does that tell us then about the lengths of HG and AI? Yes, they are congruent because we know that I and H are on the perpendicular bisectors. And so Theorem 5.2 says if a point's on the perpendicular bisector, then it is equidistant from the endpoints of that segment. So that will tell us that this side and this side are congruent. And again, this side and this side are congruent. So those are 7. Well, if we know that these two sides here are both 7, this side is 10 up here. This side is also going to be 10 because this, we know DJ is a perpendicular bisector of a segment, okay? So that means this length down here would be 20. Does that make sense? Do you see that? So now we can just add those together, 20 and 14, and get 34. Did that help? Okay. All right, Lily, number 6 and number 8 on the bookwork. Okay, for number 6, we're supposed to tell whether the information in the diagram allows you to conclude that C is on the perpendicular bisector of AB. So when we look at C, what do we know about that point compared to its distance from the segment, from the endpoints of the segment AB? It's congruent. So now go look at your theorem 5.2 and see, does that match? Does that fit the explanation there for how you know that a point is on the perpendicular bisector? It says if a point is on the perpendicular bisector, then it is equidistant from the endpoints. So is that true here? Yes, it is equidistant from those endpoints, so there is enough information to prove that C is on the perpendicular bisector of that segment. Now, if you look at number 8, what do we know about C compared to segment AB? Does the picture tell us anything? That's right. There's not enough to show any congruency there because it doesn't have any. The only thing that we know is that P is a bisector of AB, but we don't know that it's perpendicular because it's not marked as a 90-degree angle. And we don't know that CA and CB are congruent because that's not marked. And without knowing that that's a perpendicular bisector, then we can't really prove anything about it. Does that make sense? You good with that one? Okay, you're welcome. All right, Charlotte Ann, number 14, I've worked a couple times. Let me see if I can pull it up. So for number 14, Charlotte Ann, this is the theorem you're going to need to use. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of the triangle. So how can we use that information to find a point that is equidistant from the vertices? If we're looking at that problem and we compare it to this picture here, then your points A, B, and C are where your restaurants are, okay? So how can we figure out where this point is located on that other map? Okay, you're good. Anyone else have questions? All right, Lily. Number 9 says point P is inside triangle ABC and is equidistant from the points A and B. On which of the following segments must P be located? So for that one, we have triangle ABC. Oh, hold on. I'm not showing you that screen, am I? Okay, so we have a triangle ABC, and it says point P is inside of the triangle and is equidistant from points A and B, okay? So P is in here somewhere, and it's equidistant from A and B. Now, what are our options to look at? Would it be located on segment AB? Well, no, because segment AB is here. All right, and we know that P is on the inside of the triangle, so it's not on AB. Let's see. So it's not A, okay? Sorry, I have too many windows open. For B, the perpendicular, is it located on the perpendicular bisector of AB? Well, if we look at it, does that picture look like one of the theorems that we have where we know that it's equidistant from the endpoints of a segment? Okay, so do we have enough information to say that it would be on the perpendicular bisector of AB? Yes, we do. So the answer to that one would be B. Sorry, Evan, I just saw your question. Do we need to have all the postulates and such in our note cards before the quiz? No, I don't check your note cards before the quiz. And you can use your handwritten notes on the quiz. Now remember, it really is just going over 5.1 and 5.2. So make sure you're comfortable with the questions that are on your homework, on these practice A worksheets and on your book work, and you'll be fine. Yeah, I only am going to check index cards before tests, okay? Did I miss any other questions up here? Larkin, did you have any questions? Number 11 in the book, Lily, or on the worksheet? Okay, the book. Let me see if I can pull that up. Okay, so number 11 says to find NM. All right, so we need to be able to find the measure of that segment. So let's look at where NM is. It's right here, okay? Now, if we look at our picture, we see that JN is a bisector, or, well, let's see. We see that JN is perpendicular to segment MK, and we can tell that it would be a perpendicular bisector because it's equidistant from the endpoints, as noted. Oh, sorry, I went to eraser. It's noted here and here that it's equidistant from the endpoints if that line continues to go through. So that would mean that point L would still be there because that's equidistant. So we know that this line is a perpendicular bisector, so this should be equal to that. So if we know that those segments, those little parts there are equal, then what do we know the measure of NM would be? Okay, so if you look at the picture, we know that, actually, let me see if I can zoom in a little so it's easier to draw better. All right, so we know that this line, do you see how we know that this line here is the perpendicular bisector of that segment? Are you good with that? Okay, so since it's the perpendicular bisector of the segment MK, we know a bisector divides a segment into two congruent parts. So that means this segment and this segment are congruent. Well, we know that this segment's measure is 35, so that should tell us the measure of this segment too. Does that make sense? Yeah, NM is 35. So, Lily, probably the best way to work these types of problems when you're doing your work at home, look at that diagram there and then flip back in the chapter. Are you doing this with your textbook or just with the computer? Okay, so I like that because the textbook is way easier to flip back and forth. If you flip back into the section and find one of the theorems, because we know in geometry all we're using is these theorems, right? The theorems are going to tell us what to set equal to what, or what is supplementary with each other. They're basically going to tell us how to set up our equations. So if you look at that picture and you flip back in the chapter and try to find one of the theorems, one of the green box things that looks like that picture, then you can use the information that's in that green box to help you work through all of the things on that picture. So if you flip back, go to page 305, and then you can kind of look, like if you flip back and forth, you can see that that diagram there for theorem 5.3 looks just like that picture, right? So if you can flip back and forth there, then you can see on theorem 5.3, see they have the congruency marks there in the picture. So if you apply those to the diagram that's in the bookwork on that page, then that'll tell you the relationship between those different things that you know. Does that help? Okay, so, all right. Will you turn your mic on? I'm going to click back and forth between some pages, and I want to be able to hear you if you ask me a question, because if I click back on this screen where I can read all of your comments, then it goes haywire. So let me share this way. See, this is what it looks like if I try to read your comments. So, all right, if you look at the picture here in 5.3, you can see that you've got this perpendicular bisector, right? It's noted that it's perpendicular and that it's a bisector because it divides that segment into two parts, okay? And what the theorem tells us is that point D is on that bisector. Like if we continued this line down here, it would go through point D if these two sides are congruent. So if it's equal distance from A and B. So if we go over here and we look at the problem in the book, then we look at this picture. It's turned a little bit, but it's still the same picture. ignore this stuff up here right now because we're only dealing with MN, right? So for MN, we see it's perpendicular. This bisector here, it's perpendicular, right? We don't know that it's a bisector just by looking at what's marked in the picture, but the way that we can prove that it's a bisector is by seeing here on this picture, we have a perpendicular line, and these two distances here are congruent. So if you look at this picture, these two distances here are congruent as well. So that kind of goes backwards and proves that this is a bisector here. Okay?
Okay. How would you do number 12?
Number 12? Okay, so number 12 is JK. So if we look at this one, okay, we see that we have this perpendicular length, okay, our perpendicular segment. We proved that this is a perpendicular bisector because we can see down here, right, with number 11, we proved that this is a perpendicular bisector. So that means that these sides are also congruent to each other. So that looks, we know that we have two congruent parts here. So that tells us that AC and BC are congruent. So, oh, sorry, I clicked on the wrong tab. So then that would tell us here that these two parts are congruent. So those we could set equal to each other. 5y plus 8 equals 7y minus 6. And solve for y. And then we would have to plug back in to JK after we find y. Does that make sense?
Yes.
Okay. Hey, Larkin. Yes, you can put the postulates in your notes. You can put anything in your notes that you want in your notes for the quizzes. So, Lily, that's flipping back and forth like that in the section is also how those index cards will come in handy for you on your test, because that's really the information that you need to tell you what equals what to solve for everything. So if you can flip back and forth like that when you're doing your homework in the section and get familiar with how to use that information in the green boxes, that's the same information that you're putting in your index cards. So when you're on your test, look at the diagrams that are there, flip in your index cards and find one of the pictures, because you're going to have all the pictures there now. Find one of the pictures that's similar to that, and then try to tell, you know, what you can tell from that theorem, what you can prove about the diagram that you're looking at, what you're solving for. Does that make sense?
Yes.
Okay, good. So for number 13, Lily, find KL. So KL KL is going to be, you see how it's marked congruent here to ML?
Mhm.
So you're going to set 7y plus 1 equal to the 9y, whatever. I clicked off the screen, to 9y minus 13. Then you'll solve for y and then plug that back in. Do you see? Since they're marked congruent, that means they're equal to each other?
Yes, ma'am.
Yes, ma'am.
Okay. And then for ML, same thing. You've already solved for y for number 13. So just, well, really, there's not even any plugging back in because you know that they're congruent. So whatever you come up with for KL should be the answer for ML. Now, maybe a good idea to plug in and solve just to make sure that you don't come up with something different, okay? Because then that would clue you in that you might have done some of the math part of it wrong. So do you see why you would not set it equal to 35?
Kind of. It's a little
It's
confusing.
a little confusing.
Okay, so I'm going to go back on here again. So 35 is this length here, right, from N to K. Can you see when that I'm moving that little magnifying glass? Does that show up?
Yeah.
Okay. So 35 is this distance from N to K. Well, we know that NK and MN are congruent, but it doesn't tell you that these sides of the triangle are congruent to those parts, okay? What you do know is that this congruent symbol is the same as this congruent symbol, so that those two sides here are equal to each other, okay?
Okay.
Does that make sense?
A little bit more.
A little bit more.
Okay, good.